This is the first of 4 trainings that we're going to do over the next month. Today we're just going to start with computer basics. For some of you, this will seem overly simple. For some, it won't. And so I'm just setting down a baseline here of what a computer is, how it works. And then next week we'll get to how we connect 2 computers together, which is building a network or an internet. And then the 3rd week we'll go to Google specifically. And the 4th week we'll be following up. This is a little GIF or GIF, depending on who you listen to. This is a series of images all put together in a stack so that they run like a video. And it's my little representation of, here's a laptop, you push the power button, up comes something, something comes up, you wait a while, something on a black screen usually, you wait a while, and then a picture comes up and you sign in. So first I'm gonna go over what's actually going on, and then we'll go from there. A little background, so I cut out, I've done this presentation before, I cut out all the history except this one picture of a 17th century loom, and on the right, or at least on my right, are punch cards. And it turns out that computers are directly tied to the weaving industry through the punch card, which is a long, interesting story, but we won't go into it. But I use this just to say there's a lot of back history that's really interesting. And at the same time, I took this picture from the National Museum of Scotland because I'm particularly interested in my Scottish heritage and how how the Scots have been involved particularly. So that I weave that into all my stories. There's a bunch of dead white guys. They're not all dead yet, actually. So here's a bunch of white guys. I tried to get the youngest picture possible because we always see these inventors, we always see them after they've won their awards and they're wearing their medals and their ribbons. But it's actually the young people, you know, that do all this stuff. So here's a series of people that I'll be mentioning. You may have heard of them, maybe not. Most people have heard of the guy in color, Sir Tim Berners-Lee. He's still active in computing. But so there's the history lesson right there. It goes way back, and there's a bunch of people that were involved. And computers really came into being during World War II. And it's interesting that right after the war, one of the scientists that worked on the atomic bomb published an essay right after the end of the war in Atlantic magazine about computers, and he laid it all out. Here they come, we're all going to be able to communicate, we're all going to be able to store all of our stuff, and this was before anybody even saw a computer. So it's interesting that people have been thinking about this. All the ideas came first, the technology has always lagged behind. And it's the case today. People are theorizing things, you know, just amazing things that we don't have the technology to support. Ted Nelson, one of the guys on the earlier slide, in 1963, so back before when they were just typing on telexes, there was no screen involved at all. He was already theorizing the hypertext and hypermedia, which is what we use today. Hypertext just means that you and I can work on it at the same time.
What is telex?
Pardon?
What is a telex?
A telex was an earlier communication device after the telegraph, which had just one key where you had to type out each letter with one key. Then when you hook a typewriter keyboard to a telegraph, each key is a different letter, that's a telex. And then those were used to set type, you know, for printing industry. You would type stuff in before you could drop files in. So that was a technology that was used for 50 years for a lot of different applications. I'm always amazed that these guys, these early pioneers, and unfortunately they were mostly guys, were theorizing all this stuff before they could see any of it. It was all done in their minds and then typing out words. There were no graphics, no screens, none of that until later. So there's our short history lesson. It's the mathematicians that actually drive all this. So when you run into all these strings of numbers and things, there's a reason, and it's because of mathematicians. Von Neumann was the most famous mathematician in the last century, and this is his idea of a computer. Again, before there were computers, he had this all laid out, and the main thing here is the memory is a separate unit, and that's how our computers work today. And then the central processing unit does two things. One of them is computing, so that's why we call them computers, but today that's almost insignificant. The important thing is a control unit, and that's what helps you switch from your browser to your email to your photos to watching videos. And it's the control unit, it's the switching unit. That's the most important thing. But again, this is all theorized, and now we're building it. So here's a computer chip, actually a CPU. That's what the brain of a computer looks like, the little black square with all the dots. I was going to say that when I first got my hands, well, I didn't get my hands on a computer. When I first got to use a computer, it was before you could touch one. There was somebody who was paid to touch the computer, and nobody else was allowed to touch it. And we wrote programs on punch cards. So that's back to the first slide. This is in the mid-70s. And it was so slow and so annoying that that's where I knew I was never be a computer programmer. And then along came personal computers, which is what we use. And I got my hands on the first one of those in 1983 and learned how to program that, and it was just as slow and annoying. So I'm not a programmer, and I really admire people that can do what it takes for us to be able to use computers. There's a little diagram. That's what the whole motherboard is what they're called, the whole board inside your computer that routes everything. It takes all the signals in and sends them where they need to go and displays your monitor and all that. So some people have looked inside a computer, most people never have. So if you haven't, this is what's inside there. There's a green board and a lot of air and a fan to cool it and some ports to connect things. Most of the box is air of the computers buy. That's why you can have a tiny little laptop and it works exactly the same as your big desktop, because the desktop's just basically air in a plastic box. So I'm going to play this while I talk, just to point out that once you hit the power, there's that delay. And this is called booting, which originally was called bootstrapping. And when you hit the power, electricity goes to this little chip, one little chip, that can't be programmed. It can only do one thing, and that's to pass the power to another chip called the BIOS. I forget what BIOS stands for. And that chip checks your computer. And this is the BIOS screen. So while you're waiting for your computer to load, what it's doing is it's checking these thousands of settings. And you can go in and mess with these, but most people don't even know they're there, and that's probably a good thing, because you can really mess up your computer. But while you're waiting for it to load, this is what's going on. That original BIOS program, it's a very small program, after it gets handed power from the initial chip, it goes through and it checks all these settings. And then once it says, okay, the computer's fine, then it loads your operating system. I find that a lot of people aren't really aware that the computer has an operating system. So that's, again, why I do this training over and over, to break it down, break it into pieces. And I find that cake analogy is really good. So we've talked about the hardware of the computer. And then on top of that, you can break it into those little separate components, or you can just say you turn on your computer and then it loads an operating system. Everybody on this call uses the Windows operating system, I'm pretty sure. Everybody's aware of the Apple operating system. It's completely different. Apple is based, like so many of these operating systems on the screen, are based on Unix, UNIX, which is the university operating system that was developed in the 60s. jointly between private industry and university scientists. And it was never meant to be commercial. And some computers, especially in the defense department and in some physics departments, still run Unix because some of the programs are so valuable that they just have maintained them for 50 years and still use them. Most of the other systems spun off of Unix, but they never got the popularity because they weren't the business people that Bill Gates was. And so Microsoft Windows is the dominant system because of marketing, because of, the market and capitalism. It's not the best system by far, but it's the most used. And so we just have to work with it, work around it. These other ones are perfectly good. Some people swear by Apple. It has strengths, but it also has weaknesses. So after you turn on your computer, that first thing, and if that asks you to sign in, that's your operating system. This might be out of order. That last guy on the slide with 5 guys, Sir Tim Berners-Lee, sat down, and in 1 year, he basically invented the internet and all of the way that our computers are connected. It's amazing to me that one guy did that. The most important thing here is the HTTP, the Hypertext Transfer Protocol, which is how computers talk to each other. And that's why you see that at the beginning of every address.
Mark, I have a question.
Sure.
Did you say that this Tim Lee invented the internet in 1990?
Basically, that is basically a true statement.
Okay. Okay. Thank you.
Yeah, he did it. He was working in Switzerland with scientists, and he needed a way to transfer documents around the world. And so he came up with this way. The HTTP is how they're transmitted. The HTML is how they're formatted, so you can read them. It's not just endless strings of text. And the URI or URL is how you find the other person to send it to. And he invented all these in less than a year. And they're all being used today. So again, it's interesting that they're real humans, and he was 20-some years old, and he had a problem and he solved it. And so we're still using all this stuff. And it's the browser, so that's why it might have been a little out of order, but after you've got your operating system open, you can work on a Word document or edit a photograph or do things without connecting to the internet. But most of us turn on our computer to check our email. And I find that a lot of people aren't aware that you have an operating system. In our case, it's Windows. And then you go and you click and you open a browser. And it's the browser that knows what to do with the HTTP and the HTML and the URLs. It's the browser that directs the traffic and connects you to where you want to go to get what you need to get. And email, again, is the basic operation. So it's the browser that goes to your email service, and you sign in and get your email, but you're getting it through a browser. So I find there's a lot of confusion there, and this is why I keep asking, and going forward, I'll ask this question again and again of people. What browser are you using? Because we experience, as users, as my email doesn't work. Okay, but there are layers there, and so that's why I ask what browser are you using and these different questions, because we have to identify what's not working. And sometimes it's the email, like this morning, but often it's the browser. And so there's a lot of browsers. You can make your own browser if you want to. Again, it's just a bunch of code. Microsoft used to be the leading browser, used to be Microsoft Explorer, but they kind of got left behind. And they now base their new browser, which is called Microsoft Edge. That's the E, the funny little blue E. You may or may not have this on your computer. If you've upgraded to Windows 10, you might have noticed that Explorer is now called Edge. I mean, it's basically the same to us, to the user. Actually, though, the Microsoft Explorer was completely thrown away. And there's our meeting will end in 10 minutes, but I'm not going to upgrade. We'll just have to sign back in if it kicks us off. Interesting, it didn't kick us off on the last meeting. Anyway, so the circle,
I thought these were only going to last half an hour, Mark.
yeah, we'll see. The red, yellow, and green circle with the blue dot in the middle, that's Google's browser, which is called Chrome. That's going to be the browser that I'll recommend going forward, because we're becoming a Google organization using Google Apps. They just work better in the Google Chrome browser, and it helps you sign in and out of things. You don't have to use it, but that's going to be the recommended browser. And it's interesting that the Microsoft Edge browser is built on the Chrome code. Google gives that code away, and actually most browsers you use are now basically Google Chrome that have been rebranded, except for Apple's Safari. That's their own separate browser. Most of these other browsers you see are just Google Chrome that have been modified. Some of them are modified for security. I keep trying them. They're really hard to use because they have so much security built in. So it's back to that ease of use versus privacy and security. And they'll always be in tension. And the more security we add, the harder it will be to sign in and out of things. It's just, there's just always going to be that tension. So you've got your browser open. Now you want to go find something. Most people don't realize the browser uses a search engine. So the browser is making the connections, but it's the search engine, which is a separate piece of software that's actually looking for what you want. It translates, you say, how do I fix my car? And the search engine takes that language, natural language, how do I fix my car? And then translates it into computer language, and then goes out and looks around the world for things that will help you fix your car. And as the search engines get better, the results get better. So again, most people aren't aware, but you open the browser and then you're using a search engine which is separate, and you can change that. Just like you can change your browser, you can change your search engine. I use Google, again, search engine. It's the most used search engine in the world by far, and probably the best, but yet there are others. And again, you can build your own search engine if you want to. The code's out there, and then you can modify it to just look for stuff you're interested in. So some of these search engines are specific to certain professions or industries, and they're tuned to be really good at finding stuff for people in that industry or profession. Again, there are high security search engines. DuckDuckGo, which is a silly name, has a silly logo, but it's a search engine that when you use that to search the internet, nobody can see who you are. It protects your privacy, allows you to search the internet, find things and download them, but it doesn't keep any search results. And so when you use DuckDuckGo, it's like being on a brand new computer every time you look for something. And if you try that out for a while, you realize how much of your search history is saved by your search engine to help you find things more easily. And that's why when you see these suggestions, you start to type in de Villiers Sloan and it'll auto-complete to devilliersloan.com. That's all these memories and cookies and things that are left by programs in your computer to help you find things. So again, it's that privacy security trade-off. If you try one like DuckDuckGo, if you try that for a while, you realize how much we rely on cookies and saving of search results and all of that. So again, I'm just trying to make you aware of the levels. You know, again, back to that cake thing. You've got the hardware, you've got the operating system, the browser, the search engine. And so when things go wrong, you know, there are different places that have to be looked at. Most people, you know, again, don't care, don't know about this, but they also struggle when they can't get their task done because they don't know where to look. And that's when you call me or, you know, a technical expert, you know, like Sean or Eli and Mackenzie, who are closer to being engineers, and they're the ones who can actually get in there and find out what's gone wrong and fix it. So here's the basic layout with the computer at the bottom and different people reference and different dates. And I just found this useful, again, to sort of visualize that they call it a stack. There's a stack of technologies that we use, mostly without thinking about it. And if you look into any one of these, you just get overwhelmed with how complicated it is. And then when you think that, you know, they come out with 100 new computers and 500 new phones every year, and those have to be able to interoperate with everything, the complexity, you know, becomes overwhelming, which is frustrating, understandably. So that's why people pick a little thing that they specialize in and work on that. So that's basically it for today. Again, I wanted to keep it short. I want to take some questions, and then we all have other things to be doing. This is a Google slide that I made. These are the Google apps we're going to be going to. So again, once we turn on our computer, open our browser, and start to do things, the reason they're called apps is they're not on your machine. They work through your browser. They're on somebody else's machine, which is the cloud. And you'll be able to use all these different things. You'll find that you'll use 2 or 3 of them, and that's fine. But
yeah, that was my question. We probably won't use all of these, right?
no, you won't. But it's just good to know that they're there. And come on in. It's good to know that they're there, and some of them you can build a website in 5 minutes with the Google Sites. This is going to go away, but this is the quotation marks in the thought bubble, whatever. That's the Google Hangouts, which Google's breaking into texting, which is, I forget, and the video part, which is Google Meet. And so as going forward, those will be separate. But there's blogging, there's all these different things. Google Classroom, which we're using over at Wiser. Basically, you're just going to use the docs, the sheets, the slides, which is what I'm using, the yellow slide, and the purple is the forms, like when I sent out a survey that was built in a Google form. And then there's the calendar and the email. So you'll basically just use 2 or 3, but in a couple of weeks, I'll go through them quickly, but again, point out to you that they're all available and they're already hooked to your account. And so they're much easier to use than going out and finding a separate software.
I have a question.
Sure.
Which one is equivalent to PowerPoint?
Slides.
Okay, and then are we going to be storing our files on Google Drive?
Yes.
Okay.
Yeah, Google Drive is Google's consumer cloud. So as users, that's what we'll be using, storing things in there. And then there's the more technical, a real cloud, which is going to be replacing Microsoft Azure. And so again, those are different. They're kind of the same, kind of different. But we'll be directly storing our files in Google Drive, and actually it automatically. So again, when you open slides and you make a few slides, and you can even put slides you already have, put them in there. Of course, the formatting will be slightly different. You'll have to clean them up, but you can put them in there, and then they're automatically saved on your drive in your account. I'm bringing up RAP again, and I'll bring it up again and again, because it's short. It's going to be easy to remember after enough repetition. And it's when you get, when you're trying something out, especially as we transition to Google, you want to ask yourself, am I just replacing something like Google Docs for Microsoft Office Docs? That's a straight replacement, right? But when we start working together in real time on the same document, now we're augmenting. And Microsoft has added that feature recently, but that's built into Google. It's part of the basis of Google is this sharing. And so again, we'll go into that. And then there's transforms, and this is
Mark, tell me again, what is RAT?
Replace, augment, or transform. And so whenever you're working with a new piece of software or trying to do something new. Hi, Maribel. The Zoom recording ended just before we ended the webinar. And so there's just one more slide I showed, and I didn't want you to miss out on seeing my image of a rat that I made that helps me remember the acronym RAT, replace, augment, or transform. So I'm adding this to the end of the recording so I can add that image, and still the recording comes in much less than 30 minutes. So I hope you made it this far, and we'll see you next week in the second webinar.